This lecture is about solving quadratic equations by factoring. So let's write down the steps involved. First one, you need to move all terms to one side. The purpose of that is so that you can leave 0 on the other side. So the important thing is leaving 0 on the other side. Okay, so you have to have 0 on one side. Step 2 is, now that you've collected all the terms to one side, you want to simplify the expression, and then you need to factor it. So the new step in solving is where you need to set each factor. So set each factor to 0 and solve. So why do you want to do this? Is because if you are told that the product of two numbers is 0, then you can safely say that either A is 0 or B has to be 0. Okay, so that's the hidden reason behind step 3. So let's look at the example. Now you notice that 0 is specially chosen. As you can see from step 1, you have to have 0 on one side. And 0 is a very special number, because if I tell you that two numbers multiply to give me 0, then I think it's very safe to say that one of them have to be zeros. Okay, but if I tell you two numbers multiply to give me 4, for example, then you notice that you can't say one of them has to be 4, because it could be 4 and 1, it could also be 2 and 2, it can even be 8 and 1/2. Okay, so 0 is a very special number where if you multiply to get 0, then one of you have to be 0. So that's why 0 is specially chosen. So step 1 is you must have 0 on one side. Okay, so let's try the first example. Can you solve 6x squared equals 7x plus 3? So you notice that the terms are on both sides, okay, and that's no good because you need to see a 0 on one side. So in doing so, I have to bring all the terms to one side, and normally you bring it to the side that carries the exponent. So 7x is pulled over, and so is 3. And so I end up with a trinomial, 6x squared minus 7x minus 3. Since I cannot simplify this any further, my next thing to do it is to factor. So there's a trinomial because there's 3 of you, 3 terms. So I'm thinking of sum and I'm thinking of product. So the sum is the middle term, which is -7, and the product is the A and the C, which is the 6 and the 3, and that gives me -18. So using the product, what times what gives me 18, but yet the sum is -7. Okay, so -9, +2. Okay, so I'm going to use the FOIL method, and FOIL method requires you to look at f first. So I'm looking at the 6x squared, and I'm thinking what times what gives me 6. So a natural choice is 3 and 2, and it turned out to be the correct choice, because 3 can give me -9 if I multiply by something, and 2 can give me 2, okay, by multiplying by 1. So 3x and 2x. So these are my inner and outer products. So 3x times what will give me -9x. So thinking backwards, 3 times -3 will give me -9. And then 2x times what will give me +2x. And that comes out to be +1. So as far as factoring is concerned, that's it. And the extra step now is saying that these two factors multiply to give you 0. What can you say about these two factors? So the extra step that we're learning right now is that either this factor has to be 0, or the other factor has to be 0. That's because they multiply to give you 0. Okay, so one of you has to be 0. So solving this says 3x is -1, x is -1/3, and in this case 2x is 3, so x is 3/2. Okay, so the solution to this question has two answers, -1/3 and 3/2. Let's look at example 2. Okay, so supposedly now I say, can you solve 6x squared equals 12x? So, just as the first example, you notice that you have to pull everything one side, and usually you pull to the side that has the higher exponent. So it's going to read 6x squared minus 12x equals 0. Now there's something we've been talking about. Don't forget your GCF. In this question, the GCF is 6 and x. Okay, so you can take out the 6x, leaving you with the reduced polynomial as x minus 2 equals 0. Okay, so factors, set each factor to 0. Okay, that's the extra step. Set each factor to 0. Now, if you divide both sides by 6, it tells you x is 0. Just as in this case, it tells you x is 2. So in this question, there's two answers, 0, 2. Okay, sometimes the question does look a little more complex than this. For example, if I say, can you solve 3x plus 1 times 2x minus 4 equal 2 parentheses x plus 7. Okay, so I need to get a 0 on one side. That's the important part. So I'm going to bring all the terms to one side and I'm going to combine them. So if that's the case, I might as well remove the parentheses first. So it's going to read 6x squared minus 12x plus 2x minus 4. And this is by foiling. And on this side, I'm going to distribute the 2. So it's going to be 2x plus 14. Okay, so when you have a lot of terms, you might want to clean things up a little bit. So you have 6x squared minus 10x minus 4. And on that side is 2x plus 14. So the terms are drawn to the side that has the higher exponent. I'm going to subtract 2x on both sides. And I'm going to subtract 14 on both sides. So that these terms are cancelled away, leaving me with 0. Okay, but now that I have more terms on the left, I can try to simplify the expression. And in this case, I end up with 6x squared minus 12x minus 18. So this is a trinomial. Now before I jump to doing sum and product, don't forget something else. You have to look for GCF, because GCF kind of helps to make your numbers smaller. So you notice 6 is common. I can take out the 6, leaving me with x squared minus 2x minus 3 equals 0. Okay, now this reduced polynomial that you see here, the sum now, I'm looking at minus 2 and the product is minus 3. So you notice it's a lot smaller compared to the original one right here. So this 2 gives me the two factors to be -3 and +1. Okay, and so 6 is my GCF, and the two factors are x and x, minus 3 and plus 1, and is equal to 0. So just as you saw in example 2, I'm going to set each piece to 0. So 6 is 0, x minus 3 is 0, and x plus 1 is 0. But unlike the first case, you notice 6 equals 0 is a contradiction. So 6 cannot be equal 0. So there is no solution from this one. Okay, so there's no contribution from the first one. But x minus 3 is 0 tells me x is 3, just as x plus 1 is 0 tells me x is -1. So in this example, my two solutions are 3 and -1. Okay, so let's try one more example, and then I think you should be ready to try the problems for your homework. So let's solve, for example, x squared plus 4x minus 5 and 3x plus 2 equal 0. So do I do this problem like I see it in example 3, where I FOIL? Okay, this is the part you need to see the difference. In example 3, you notice the terms are on both sides of the equal sign. I don't see a 0. Okay, so that tells me I have to bring the terms to one side, and when I bring them to one side, I need to combine them. And when I combine, I can't combine when they're still in their own little parentheses. But in this example 4, do you notice the 0 is already there? 0 is here. Okay, so if you see a 0, then you are pretty much almost good to go. If you look on this side, it's kind of factored except for this one. This one can be broken into 2, but the 3x plus 2, you should leave it. So notice that this question is actually partially factored for you. Okay, it's already partially factored, except this you can continue. So I'm looking at the trinomial sum being 4 and product being negative 5. So that tells me the two numbers should be positive 5 and negative 1. So x and x, positive 5, negative 1. Okay, so now I have 3 parentheses, setting each parentheses to 0. X plus 5 equals 0. X minus 1 equals 0. 3x plus 2 equals 0. Okay, so this tells you x is negative 5. This tells you x is 1. And this one, 3x is negative 2. X is negative 2/3. So in this case, I actually have 3 answers. And my 3 answers are negative 5, 1, and negative 2/3. Okay, so now that you kind of understand how to do equations, solutions of equations, so why don't you try some from your book before you do the ones on the review sheet? Let me give you the questions. Okay, can you try the ones in your book? This is on page 284. Can you work on numbers 41, 47, 51, and 61? So in the next video I'm recording, I'm going to do these 4 problems for you, and as if we are doing in the class, and I'm also going to do some of the ones in the review sheet. Okay, but you have to try them first, alright? So can you work on these first, and then you can watch the other one to look at the solution. Alright.